Hello, this is Dr. Amudapriya, Associate Professor Triply from Rohini College of Engineering and Technology, Palkulam. We are discussing about the protection and switchgear course, which deals with the busbar protection and zones of protection and regarding CTs and PTs in this lecture. Busbar is not going to perform any actions. The transformer will be changing the voltage levels. Generator will be converting a mechanical energy to electrical energy. A motor can convert an electrical energy into mechanical energy. A transmission line can transmit the electrical energy from a place to some other places. Likewise, each and every parts of the power system has a specific actions. But what is the role of a bus bar? Actually, bus bar is used for connecting the feeder points or the transmission lines at a specific center. This is what is the purpose of a bus bar. So the protection scheme for a power system should cover the whole system against all the possible types of faults. So in this case, we are considering the busbar zone. Although the faults in the busbar zone are cleared only after some time delay, unrestricted forms of line protection such as overcurrent and distance systems meet this requirement. If unit protection is applied to feeder and plant, the busbars are not inherently protected. Busbars have been left without specific protection. Such a cases, busbar faults, like majority of bus faults involve LG fault, but faults arises from many causes. Majority is LG fault. With fully phase segregated metal clad gear, only earth faults are possible, and a protective scheme needs to have an earth fault sensitivity only. For outdoor busbars, protection scheme's ability to respond to interface faults, the clearing of the earth is an advantage. While considering the protection schemes, it involves a system protection which is used to cover the busbars, or frame earth protection, or differential protection. Next, while you are considering the system protection, we can see that a system which includes the overcurrent or distance systems will inherently give protection to cover the busbars. Overcurrent protection only will be applied to relatively small distribution systems, or is like a backup protection it is used. While considering the distance time protection, it will be covering the neighboring zone also. In both the cases, the busbar protection which is obtained is slow only. While considering the frame earth protection, this is purely an earth fault system, and in principle it involves simply measuring the fault current flowing from the switchgear frame to the earth. So we can see here to this end, a current transformer is mounted on the earthing conductor and is then used to energize a simple distance relay. Here how is it? So while you are considering this protection part, we can see, so this is a unit of metal clad switch gear, and suppose this is a earthing bus which is being connected to the concrete foundation, and this is a fixed part. At this earthing bus is then connected to a CT, that is a current transformer, which is parallelly in connection with the earth fault relay. So obviously what will be there, what will happen is the CTs will be receiving the earth fault current through it, which is being suspected by this relay operation, and obviously the fault current will be switched over to the earth. So this is what is happening in case of this busbar protection. Next, zones and types of protection. Normally, zones, already we have discussed in the earlier lectures about what are the zones. There are different zones, generator zone, transformer zone, then busbar zone, transmission line zone, then consumer load side zones, etc. All these zones will be individually have to be protected. So what will be happening is they will be provided with some primary protection. Those primary protection, it will not only cover that particular zone. For example, next to the generator, transformer will be there. So the zone which is protecting the generator will be protecting the transformer also as a secondary one. The next, the transformer zone which is being provided with a specific protection, It will cover the generator zone as well as the bus bar zone. So likewise, the neighboring zones of protection will also be overlapping with each other. Why is it so? If suppose the protection system fails, obviously the next one will be helping for the protection. So we have already seen this diagram in the earlier lectures. And now we are going to discuss about the types of protection. What is primary protection? The primary protection scheme ensures fast and selective clearing of any fault within the boundaries of the circuit element. That is the particular zone which is going to be protected. For example, in zone 1, it's a generator zone. It has to be protected. So primary protection is for generator only. That zone will be covering the transformer zones. So when it is covered transformer zones, the primary protection is for generator and the backup protection is for transformer. Likewise, similarly, for a transformer zone, individually a protection scheme will be provided. It will be protected. Primary protection will be given for the transformer, but that primary protection will be acting as a secondary protection for the generator as well as the bus bar. This will be the cases. Right. So primary protection as a rule is provided for each section of an electrical installation. However, sometimes the primary protection may fail. The primary cause of failure of the primary protection system are current or voltage supply to the relay, DC tripping voltage supply, protective relays, fault in that, tripping circuits fault, and then if a circuit breaker fails. All these failures may lead to the primary protection failure. Backup protection is the name given to the protection which backs the primary protection whenever the primary protection fails in operation. So normally backup protection by definition itself is lower than the primary protection. It should not be quicker. It has to take place after some time, or it has to be intimated that the primary protection has failed, and so the backup protection has to be in action. The design of the backup protection needs to be coordinated with the design of the primary protection. So essentially it is a second line of defense, obviously. And next, while you are considering the current transformers and the potential transformers, they play a key role in protection schemes. Current transformers are generally used to measure the currents of high magnitude. Actually, in laboratories, we'll be using an ammeter for measuring the current. But in large transmission systems and distribution systems, we need to use current transformers for that purpose. So obviously, it is used for measuring the currents of high magnitude. These transformers step down the current to be measured so that it can be measured with a normal range ammeter. A current transformer has only one or few number of primary turns. We can see in the diagram itself. Let us see. So this is the case. The primary winding may be just a conductor or a bus bar placed in the hollow core. We can see this is a hollow core. The blue color core is a hollow core through which the primary conductor is being passed through. The secondary winding has large number of turns, accurately wound for a specific turns ratio because it has to be stepped down. So for stepping down, the secondary winding will be having a number of windings, and that is parallelly connected to a ammeter. Thus the current transformer steps up the voltage while stepping down the current. Now the secondary current is measured with the help of an AC ammeter. The turns ratio we know NP by NS is equal to IS by IP. These are the areas where CTs are being used for and the protection purposes. And next, regarding potential transformer, they are known as voltage transformers, and they are basically step down transformers with extremely high accurate turns ratio. Protection transformers step down the voltage of high magnitude to a lower voltage which can be measured with a standard measuring voltmeter or a multimeter. These transformers have large number of primary turns and smaller number of secondary turns because it has to be stepped down. A potential transformer typically being expressed, for example, if it may be 600:120 ratio, primary 600 voltage and secondary 120 voltage. So this is a diagram of a potential transformer. Here we can see the high voltage which is being parallelly connected. Actually, the current transformer can be connected likewise in series. The potential transformer has to be connected in parallel. This is being connected, and here we have an voltmeter. This is why we have secondary smaller number of turns and primary larger number of turns. It is parallel to the load. Thank you.